G'day everyone, and welcome to the video on the systems of linear equations. In this video we're going to have a look at solving simultaneous equations with two unknowns or three unknowns or really any number of unknowns, to be honest. In year 12 I guess you really only sort of see two or three, but they could ask you more than that. I guess you've probably seen that more in year 11. So what we're going to focus on a little bit more in this video is, I guess, showing you how to use matrices to solve this, or using matrices to represent the data in a similar sort of way. So I'll just get straight into it. Again, you don't need to know a lot about matrices. You just need to know how to multiply two matrices together, which we sort of covered in the previous video of transformations of matrices. So this system of equations here, 2x plus 5y equals 11, negative 3x plus 2y equals 12, that can be expressed as the matrix equation. And if you have a look here, the 2 is there, the 5 is there, and the 11 is over there. That works because 2 times x plus 5 times y equals 11. That's what our equation is there. So this top column this top row multiplied by this column will equal that number there. Okay, and the next one, to get the next equations, equation, it would be negative 3 multiplied by x plus 2 times y equals 12. So in a different color, this row here multiplied by this column will equal that one there. Okay, so again, I think you've seen that sort of thing, but now we're going to look at when there's three unknowns. Three equations with three unknowns, x, y, and z. All of these equations here, they can be solved very, very quickly and easily on your calculator by using matrices. I know that you could also solve this on your calculator, going the old-fashioned way of solve. I think you've sort of seen this before, but 2x plus y plus z equals negative 1, and space and then write the next equation, space and then write the next equation, and then comma x. Y and Z, and it'll give you the solutions. But it can be a little bit tedious because that'll run off the edge of the screen to do this. You can actually solve these on your calculator using a matrix, which I can show you a little bit later. But first we need to just represent this data here into a matrix form. And so here it's as simple as what I was doing there before. You just it's one more complication because we've got an extra variable. So this first equation up here can be written in this matrix because 2 times x plus 1 times y plus 1 times z equals negative 1. That's the equation up there. The next line doesn't have an x. It's got a 0x in there. So therefore 0 times x plus 3 times y plus 4 times z equals negative 7, and that's there. This next one doesn't have a y, so I'll just have 0y plus in there. So 6 times x plus 0 times y plus 1 times z equals 8. So this matrix equation here is now a representation of that system of linear equations. And I might at this point just show you how to solve this on your calculator. Okay, so we'll go to our calculator, and I'm going to solve this on the calculator. So I'm going to say solve, and I'm going to put in a matrix. The matrix can be found using this button just here, and it'll ask me, rows and columns. I want 3 of each in this case. So 2, 1, 1, 0, 3, 4, 6, 0, 1, and I'm going to multiply that by the other matrix, which is this, and I want I want 1 column, but I want 3 rows. So I need x, y, and z, and that equals this same sort of thing, and I just want 1 column. Thank you. And I'm going to put negative 1, negative 7, and 8, and I'm going to say solve it for x, please, and it tells me x is 1, y is negative 5, and z is 2. And I guess you could prove that by solving it the old-fashioned way of going solve 2x plus y plus z equals negative 1, and yada yada yada. But I don't want to do all that. You can do that in your own time if you want to prove it. Okay, so the only other thing now is I'll just say one more thing about the systems of linear equations. So I'll go back to this one. The only other thing that they will I sometimes do in an exam is they can actually switch around the order a little bit. So they'll give you this information here. I'll just rub out these little bits. They'll give you this information here, and they'll say which one of these is the same as that, and they'll give you a whole bunch of multiple choice answers, and some of them will be incorrect, and obviously the one of them will be correct. So let me just show you an equivalent matrix that also is the same as this one, and also the same as that one. So this here could also be written as 0, 3, 4 x, y, z, and that is going to be now is -7. I need a little bit more space here, but I think you can kind of see where I'm going with this. That can be now -7, and then the next one I'll just make it 6, 0, 1, and that's going to be 8, and then the last one is going to be 2, 1, 1, and that gets me -1. Because if I multiply these out, 0 times x plus 3 times y plus 4 times z equals -7, I still get back to that equation. So this matrix here is equivalent to this matrix over here, because when I multiply them out, I get the same equations. So that's important to know that we can do that sort of thing. But that's probably the extent of that kind of thing for matrices. So you can have a go at practicing some of these if you want to. You can put some of these in the linear equations, and go ahead and solve them too on your calculator. It might be worthwhile. So that's part one of systems of linear equations, and the next we'll go on to solving equations using matrices.